Now, welcome to the lecture 3 of digital signal processing. Now, what is system? A process to produce another signal. For example, when we give a certain signal at input, system works and it produces another signal as output. Casual system. If output of a system is dependent on previous version, so it is called casual system. For example, this is output and it is dependent on previous version n-1. एग्जाम्पल हम कंसिडर करते हैं y of n is equal to 1/5 summation माइनस इन्फिनिटी टू इन्फिनिटी x of n minus k. इसमें हमने we have to tell that whether it is a casual system or not. Now we open the summation. When we put negative value, it become plus, like x plus 2, x plus 1, and when we put positive value, it become n-1, n-2. So because of plus values, it is non-casual system. Now we consider the linearity of a system. We can check the linearity of a system by checking two characteristics. One is homogeneity and second is additive. Homogeneous system has same scaling for output and input. Means if I multiply a input with the multiple a, then the system works and it produces a output with same multiple. For example, y of n is equal to x of n plus 3. We have to prove that it is homogeneous or not. Let z of n is equal to alpha x of n. From here we manipulate that z of n is equal to z of n plus 3. Put value of z of n. Alpha x of n is equal to alpha x of n plus 3. Now see that both have same scaling. Next property is additive. If we add two input signals, then the output is equal to the sum of the output signal. For example, if x1n has output y1 of n, then x2 of n has input y2 of n. Now if we add two input signal, then their output signal is also the sum. We consider the example x1 of n is equal to x1 of n minus 2x n minus 1, and x2 of n is equal to x2 of n minus 2x2 n minus 1. We consider whole this as y1 of n and this as y2 of n. I made a mistake यहाँ पे 1. Let z of n is equal to x1 of n plus x2 of n. From here we manipulate that z of n is equal to z of n minus 2z n minus 1. Now put value of z of n, which is x1 of n plus x2 of n. From here we put z x1 of n plus x2 of n. I forgot to write into n. Now we multiply both of them with n minus 1. One become 2x1 n minus 1 and second is 2x2 n minus 1. I write it with x1 n, so it becomes y1 of n, and I write this with this one, so it becomes y2 of n. Next we consider the property time variant. Time variant means a signal which depends on time, and time invariant means a signal that does not depend on time. The time increase at input is equal to the time increase at output. Means if I increase the time by 3 times, then the output is increased by the 3 times. Example हम consider करते हैं y1 of n is equal to x of n minus 2x n minus 1. Let z of n is equal to x n plus n naught. From here we manipulate that z of n is equal to z of n minus 2z n minus 1. Put value of z of n. Value of zn is x of n plus n naught. I write it over here, and in place of here I write x of n plus n naught and minus 2x n plus n naught minus 1. Now I shuffle it, n minus 1 plus n naught. Now the time which I change over here is the time which is produced at the output, so it is a time invariant system. Now consider another example. Y of n is equal to x of n minus n square. Let z of n is equal to x of n plus n naught. From here we manipulate z of n is equal to z of n square. Put value of z of n, x of n plus n naught is equal to x of n plus n naught का square. When we open the square, n square plus n naught square plus 2n into n naught obtain. Now here we increase by n naught and here n naught square plus 2n into n naught obtain. So it is time variant. Now we consider two basic type of signals. One is unit step and second is unit impulse. Unit step has all the values 1 for the number greater than 0 and 0 if n is less than 0. And unit impulse function has value 1 only at n is equal to 0 and 0 otherwise. How to convert unit step to unit impulse function? We have to take its derivative, and if we want to convert unit impulse to a unit impulse, we have to take its interrogative. Thank you.